All right, this is just a quick reminder of some velocity things, and we're not actually going to calculate all these, but it's worth just reminding us of. An ant moves along a ruler, so its velocity is given by that equation, sine of pi t squared. The position of the particle at its position time t is g of t, time t is 0, g of 0 is 2. So its initial position is 2. So acceleration. Well, acceleration, remember, is the derivative of velocity, so it would just be v prime of 2, which we could just do on our calculator with n deriv. Total distance traveled. Well, total distance, when we move from velocity to some kind of distance or displacement, it's got to be an integral. But because it's distance, it's the absolute value of velocity. Because, and I did graph it down here, we want to count, this positive area, this negative, this positive. We want to count all of it as positive area and just add it up. So it's the integral from 0 to 3 of the absolute value. Now to find its position, well, now we actually do care that it moved forward and backward. So we're going to integrate from 0 to 3 just the velocity, because we do want to include the fact that yeah, it moved forward, but then it also moved backward. But we then also need to remind ourselves that it had an initial position of 2. So it asked us for position, we need to then say it's 2 plus. If it asked us for displacement, we wouldn't include the 2, because we just were wondering how far it moved. But because we're asked for position, we need to add the 2 in. Now, last one, find when it's furthest to the left. Well, we certainly could do candidate test here and find the position at each of these points. But I think another way to argue it is that the areas here, this positive, this negative, and so on, are diminishing. Each area is getting successively smaller. So if I think about this ant moving, it starts at a point and it moves forward. It moves to the right. Okay? And that's represented, of course, by this positive area. Then it moves back, but it doesn't move back as far as it moved forward. And that's represented by this negative area. Well, then it moves forward again, but not as far forward as it moved backward. And this continues. So when is it furthest to the left? It's at its starting point. It's at time 0. Okay? And you could argue that in a lot of different ways. You could argue it as we just did, talking about that the areas get successively smaller. You could do it with candidate tests and actually figure out the position at each of those points. But either way, we'll argue that.